angiotensin aldosterone pathway. Now there are two things, remember, that cause renin to be released. Everybody remember what they were? We talked about it just a minute ago. Released by JGA when blood pressure is too low and when salt infiltrate is too low. Know our steps by now. Renin activates angiotensin. Angiotensin raises blood pressure directly because it causes vasoconstriction all over the body. It also causes you to become thirsty. That's another thing angiotensin does, and you drinking. And then it releases aldosterone from the adrenal cortex. Aldosterone is the salt saver. So over here on my drawing, I'll take the principal cells away because they're not involved here. Here's my cells in the DCT. Here comes aldosterone. Aldosterone causes these cells to allow sodium to go from the filtrate into the blood. What always follows sodium? Water. Water follows the sodium. And rectify both of these things right here. My blood pressure goes up, and that's what I wanted to happen. And salt in the filtrate was too low, and that's sort of a message to your body that you need to save all your salt, because not much of it's going out. And so all of the salt is, or I shouldn't say all, but more salt is pumped into the blood, and that saves salt into the filter, or that'll save salt in your blood, which will eventually go back and become filtrated later on. So we're rectifying both of these problems right here. Raising blood pressure, and we're saving salt, which we know is low. Okay, part of our homeostatic mechanism, remember? Homeostasis uses those little negative feedback mechanisms, and this is a perfect example of a negative feedback mechanism, how aldosterone causes those two situations to be solved. And here's the last one, and we've talked about it before, atrial natriuretic hormone. And remember, it comes from the walls of the heart. Blood pressure is too high. Walls of heart stretch too much. Atrial natriuretic hormone is released. ANH released. Causes salt to stay in filtrate. In other words, the cells in the walls of the DCT won't let sodium out, so it stays in the filtrate. And because of that, salt goes into the urine. Water follows. Water volume of blood goes down, and blood pressure Okay, so those hormones, anti-diuretic hormone, adrenaline-tree-retic hormone, and in the pathway, renin, angiotensin, aldosterone, they act on the walls of the DCT to determine how much of that remaining 20% of filtrate is reabsorbed and how much is allowed to go out and become urine. Okay, we'll save secretion for next time. We'll stop right here, save secretion.